First off, aquaponics, if you aren't familiar, fish eat fish food. They poop out fish waste and their nitrogen through respiration, which is also a large part of the nitrogen in aquaponics. The microbes break down those different fish wastes into plant food and then convert the nitrogen into mostly nitrate. And actually, there's a really interesting paper about cannabis recently about them wanting no more than 10 to 30% ammonia and the rest of it nitrate. So it kind of explains why aquaponics grows a little bit faster for a lot of these woodier crops. But it basically becomes plant food. The plants strip out the nitrates, which is toxic to the fish. This is how we set them up more on a small scale. You can see here the soil layer above the flood and drain portion of it, and with a media base in the bottom half of the pots. And I'll kind of give you a little example. And you can make this out of a concrete mixing tray or a regular grow bed. If you have an overflow filter for your aquarium, you can run that to a centralized sump tank and easily plumb your aquarium to your grow tent, no problem. So I wanted to kind of touch on this concept of thinking of aquaponics, especially organic hydro, as more like aquatic soil. You have tons of different aquatic food webs going on, lots of different microbial chains breaking down phosphorus, potassium, chelating iron, manganese, and all these other things in the aquatic realm. And I actually have a couple other slides I can show you from a different deck that have a lot of those microbes that have been found. There hasn't been a ton of testing on the different species yet, but there's more of those being done all the time. So it's definitely something that I hope, I know you have access to a lot of that stuff and more than I do at the moment. So I would love to help. Send you some samples.
Oh, yes, please.
And we also see other things that we don't see in soil. So we see benefits to it with in terms of expressions of cannabinoids and terpenes that we don't see. So, for instance, transneridol and neridol, mononeridol are both heavily found in aquaponics and heavily expressed much more than the same cuts in soil as one example. So, it helps you cue in on certain medicinal compounds that you might be interested in if you're looking down that. And we'll get into that. So this is the basics of dual root zones. So we have a soil layer on top. We have a burlap layer or other root permeable cloth. Doesn't have to be burlap, but just something the roots can grow through that still holds the soil up above the water, because we're not trying to get a wicking bed situation going. We want to have those two areas of control. If I want to partially water stress this by reducing the amount of moisture in the upper part of the root zone, it's still going to trigger a minimal hormone response on that and help increase THC and things like that later on in the production. So we still want to have those two different layers of control up top. And then the bottom half here is our media. So we tend to like to use lava rock because it's high in silica and many other trace elements when we're doing commercial stuff. But if you're doing anything on a home scale, hydrogen is just fine. If you're going to work with it all the time and get your hands in it, hydrogen is much more forgiving on your hands than lava rock is. So what happens is when this water level goes down, either because of a loop siphon, bell siphon, or a timer, or whatever other method you want to use for flooding and draining, the air gets pulled down through the top of the pot here and drafted down through the soil because of the suction action of that water going down, and drafts fresh air into the root zone and both in the soil and the lower half. And when it goes back up, it pushes that old air out, so increasing your oxygen exchange and everything else in the root zone, which really helps with a whole bunch of different stuff in terms of microbial happiness in the soil. And with this too, what the other cool thing is say if I want to grow raspberries, blueberries, elderberries, I can do an acidic soil mix that's much more akin to what that plant wants and help it thrive and help increase production of it that way, while still having the same aquaponic base for my lettuce and my tomatoes and everything else in the system. So you can kind of use this method to dial everything in on a per plant basis. And that's a happy plant there in one of the nurseries.
Yeah, it is.
You can also see the flood and drain layer there on where the dirt or the mud on the side of it ends. So, so here's a dual root zone cabbage with a little aquarium pharmaceutical ammonia tester on it that we grew for one of the employees at Aquaponic Sources kiddo for like a grow contest for their school. And then you can also see here example of dual root zone lemon tree in a 55-gallon drum. And we did this with Saturn peaches. We did this with avocados. We did it with a whole bunch of different trees, and it worked really well. Moringa works really well this way. So Well, moringa does fine in media beds too. It's not too special. But if you are looking at any of the stone fruits or any of your more trickier fruit trees, and you want to have something in the corner of your greenhouse, this can be a great way to integrate it into your aquaponic system and have it still be watered by the aquaponic system. The biggest thing with the trees was that we didn't water them as often. So we were watering them like every other day with the flood and drain portion and giving them a longer dry down period. And we were only flooding the bottom third to a quarter of the pot versus half and half. So that was the thing that kind of had to be adjusted for the trees. It seemed like that they did a lot better with those conditions. So this is a R&D greenhouse we had in Colorado. We tried all different types of stuff. We had a gas propane recirculating water heater. We had solar heaters. We had compost heaters on this. We did combos of everything to try and figure out climate control models and things like that. It was a lot of fun. So here's some cucumbers growing in a commercial facility, of commercial aquaponics facilities, or cucamelons. Actually, they're incredibly addictive. If you've ever had cucamelons, they're more addictive than potato chips. And you can see here we had slug problems, so we just put a little diatomaceous earth around them to keep the slugs away.
Wow.
Here's an example of pumpkins, another aquaponics facility in dual root zone. And then here's an example of root crops. You can do turnips and beets and things like that as well in your media beds and get them above that flood layer so you get proper formation. Carrots as well, if they hit the water, they get real stringy. They won't actually produce any mass. But with this, with the soil, with that even exterior pressure and everything in the upper portion, it really allows them to grow and form nice for commercial resale.
So you set the percentages for the plants inside each individual pot so that you can have the system handle annuals or perennials or whatever, and it's all set to each individual through their pot, right?
Yeah. So for instance, for the most part, yeah, the only exception would be maybe things like, pumpkins or watermelons or tomatoes or peppers, stuff you're going to grow a really long time. You might still top dress or top feed a couple times throughout the grow cycle. But for the most part, if you're using good healthy compost and good soil and everything and add a little extra aeration to it, you don't have to add a whole lot.
Is that strictly Korean natural farming based compost?
So we use all different types of stuff depending on the client. Half the time we're just buying a decent soil. There's a couple of companies we really like right now that are doing really good organic soil. Yeah, for the most part, it kind of just depends on a per farm basis more than anything else. Here's a elderberry tree. Marty's growing that out there. We actually have a big elderberry tree here at one of the farms I work with as well. The one that we have here is about 8 times the size of this one. So this one's I got more recent pictures of. So
wow.
But again, you can see the soil portion in the upper part. And it's just on a 55-gallon drum cut in half, as part of a regular old aquaponic system. So, and again, this is something that likes a little bit more acidic soil and doesn't really like the same conditions as most other stuff, but you can top feed it and top dress it and really push production on it. So you can see here, it wasn't until we did dual root zone expression or dual root zones that we actually hit the same yields. It increases yields of cannabis between 30 and 50% when compared to media bed controls. It really does make a huge impact. It also increases terpenes, flavonoids, cannabinoids, and a whole bunch of other key metrics regardless of what you're growing. Here's an example of a couple things. So I'll show you these tomato plants and they're alive, but the left tomato, the longer rooted one, it was in a dual root zone. The right one was just in the media bed. The left one had 44% more flower sites and fruit that was ripe 2 weeks before the one on the right did. And that was the very first trial that we did with any fruiting crops with the dual root zone before we started working with it with cannabis.
I think you may be sequestering more carbon because the roots are so big, they're putting off so many more exudates. And so this may be a way to kind of like bend the rules and get plants to create even like much more carbon into like through photosynthesis.
Oh yeah, again, we're still just learning all the different things that this is benefiting from the plant. One of the biggest things we've noticed is powdery mildew, botrytis, fusarium. We have much fewer issues with that. We don't have any issues with pythium or root rot at all because you have those living fungi in that upper portion of the root zone that are producing exudates and all those other things that are just completely obliterating them or outcompeting them entirely. So that's been another big benefit we've noticed, is especially with powdery mildew, we're not having anywhere near as much of an issue than we did before we had the soil involved. So it certainly is increasing that. We also can provide most of the nutrients. Again, we're mostly having to add nutrients in the systems as far as iron and manganese, just because of the way that gets broken down with oxidation in the aquatic environment. Iron just doesn't stay unoxidized very long in water. So, and you have to have it in that Fe2 form where they don't really want to touch it. So that seems to be the biggest thing. And then occasionally a little tweaking with micronutrients. Molybdenum, remember, and people don't talk about this, gets plowed through much faster in aquaponics as well because of that nitrate conversion in the plant. So the plants strip it out of systems much faster than hydroponics. So you can see here, those are the same two plants with the longer roots. There's the one in the pot, and then the other one is right there next to it. And you can see here, this one's had fruit that was well set before that one had even, gotten to flowering. So it was almost a comical difference.
Beautiful.
So as far as cannabis goes, we've noticed anywhere from a 15 to 20% increase in THC. We've noticed some cases up to 100% increase in CBD, with 30% being an average increase in CBD cultivars. And then we've noticed a 30 to 52% overall yield increase in comparisons. We've also noticed huge spikes in THCV and CBDV when it's configured properly, as well as CBG. And so we've hit 17% in some internal testing with THCV in some of our tests. So it certainly, again, it gives you a lot of knobs and dials to turn, because you can create that soil mix in so many different ways. You can do whatever you want with the aquatic biology. It just kind of gives you more knobs and levers to turn,
Yeah, and it just seems like this is a completely new way of going about it because of this breakthrough.
Oh yeah, and to me, it just makes so much sense. Of course, the plants are going to do better if they have a second biome, that they're exposed to. Why wouldn't they have a healthier immune system that's more reactive and producing more secondary metabolites? So, so we've had a pretty big increase with terpenes as well. Again, almost all of our stuff is testing at 2.5 or higher. Many of them over 4%. So we're not doing too bad on that. This is the other cool thing, is you can grow tons of different fungi. This is all stuff that was just inoculated from IMO. None of this stuff was stuff that we added. This is just stuff that just found its way into the soil through our normal inoculants. So this, having living soil like that, you're not going to end up with, all kinds of weird mystery fungal problems. If you have healthy mycelium that are throwing fruit off like that, they're clearly keeping that soil nice and healthy and giving the same benefits that you see in living soil beds. So you're just doing it on a little bit smaller scale. Here's an example of with and without supplementation. On the left was a farm that was following all the supplementation. They had someone come in and try to convince them that they didn't need to do that, and switch to an aquaponic fish food that had all the nutrients in it. And the mineralization doesn't work quite the same way on that. And you can see here, without just a small amount of supplementation to adjust it, it can go south pretty quickly if you have a pretty major adjustment in that. So definitely avoid people that are trying to sell you fish feeds that will fix all of your nutrient problems. It doesn't work. Here's an example of a run that Marty and I did for our educational classes. And you can see here in the front row is no supplementation. It's kind of hard to see the middle row there because it's almost hidden by the front one. But the middle row is just with vermicompost tea. And then the back row is the same thing with just 10% additional nutrients on top of all the rest of it. And you can see it makes quite a bit of difference, even at those very tiny levels. Just giving a little bit of minerals for them to work with makes a big deal.
And that's Korean natural farming, correct?
We did Korean natural farming stuff. There's a little bit of organic mineral supplements, but nothing that's synthetic, nothing petroleum based or anything like that.
Nice.
Yeah. A lot of that stuff just kills fish. So we have this forced honesty with aquaponics because I can't cheat. If I cheat, the fish die. And then it's kind of obvious that I cheated. So, and you can see here on the left is with the supplementation, on the right is the unsupplemented. And you can see here, you could still smoke the one on the right, but you'd rather have the one on the left. Let's just be honest.
It's stressed. You can totally tell it's stressed.
Yep.
Yellowing. Burnt tips too.
Yep. So, and you can see here again, there's another comparison. Again, we talked about the 38 to 46 additional plant sites and yield, a huge reduction in powdery mildew, a big increase in flavonoids, increased growth rates as well. In flowering, we get 7 to 15% increase in a reduction in total flowering time. So we have faster turnover for our facilities as well. So here's an example of dual root zone DWC versus media beds. The DWC is a little bit cheaper to set up because you don't have to buy the media and you don't have to deal with all that. It's also better for colder climates because it acts as a thermal battery. You can basically heat the water and heat the facility much cheaper that way. Whereas the media beds have a little bit faster grow times because you have that better gas exchange. The better gas exchange in the soil going up and down. Whereas you don't have that gas exchange in the water. You have aeration and stuff, but it's not quite the same growth rate as the media beds when we've done side by sides. But they both work well. The DWC is really nice for converting existing lettuce facilities. And then you can see here, we've tried a whole bunch of different things. We've tried wicking beds, we've tried media beds, we've tried DWC up there. In the top right is Green Relief. I used to work with them back when they first got started. You probably heard of them if you've ever looked up aquaponic cannabis. They were the first ones to get a commercial license in Canada doing it. They did a whole bunch of trials as well, aside from the stuff that we did in Colorado. But basically, the best results we've had were with the media beds. DWC can work, but wicking beds, we just had too many issues with the last week or two having just problems with the roots dying back, right? The same way that the plant's dropping off fan leaves, it's starting to cut back on how much it's feeding its extended root system. And when you have that much microbial activity in the water ready to break everything down instantly, we were having issues that last week or two. I think we could solve it now, especially with regular liquid IMO or labs dosing right at the end. I think we could definitely pull it off. But at the time, we just didn't have the knowledge. I wasn't exposed to create natural farming back when I first started this stuff. So I think we could do it now, but I don't think it's viable in terms of commercial production because it's just too finicky. And when you're at a commercial scale and you have thousands of plants, anything that's finicky is not worth your time.
Yep. So what are the fish eating?
Sure. So we actually have a wide range of different fish feeds. So for the most part, we'll use traditional game feed, and then we'll supplement that with labs curds. That's one thing that we feed all the time. And labs curds is really good because not only does it have vitamin B and a whole bunch of other proteins and fats in it, but it also reduces fin rot, we've noticed. So bluegills and yellow perch really like to beat the living crap out of each other in aquaculture settings. And they often will get fin rot because they nip at each other all the time. Well, we've noticed since we fed the labs curds, they don't get those secondary fin rot infections. We're not getting the weird fungal infections. We're not losing like a random bluegill here and there because it got beat up. Like they just don't seem to be, anywhere near as affected by that when they do beat on each other a little bit. So that's really helped with mortality rates, especially with the more aggressive fish species in aquaculture, and something I think you're going to see in the future. The other cool thing that we've, and there was actually a study at KSU with labs, Kentucky State University, and they showed that increased fish growth rate by 15 to 18%, but increased plant growth rate by 15 to 20% when they were doing it across a bunch of different plants. So lactobacillus is really good for adding to your aquaponic system. The other cool thing about labs, and I've used it 3 times this way to treat non-human pathogenic E. coli when people test it hot for it in their systems, is using lactobacillus to treat the E. coli in these commercial systems without breaking the mineralization cycle. So we were able to treat them after 30 days at a dose of 1 to 1,000 and completely eliminate any detectable E. coli as far as what the food safety people were concerned about.